Assalamu alaikum. My name is Mahnoor and I'm from the Department of BS Biotechnology. The topic today which I'm going to represent is polyamide resin. The table of content includes introduction, chemical structure and types, manufacturing, properties, application, and conclusion. The introduction of polyamide resin includes polyamides are the organic compounds. They consist of carbon, hydrogen, oxygen, and nitrogen atoms, which are typical atoms found in organic chemistry. The polyamide group, which contains the amide linkage, serves as the backbone of the polyamide chains. This amide linkage is formed by one of the carboxylic group from the carboxylic acid from one of the molecule and one of the amino group from another molecule joined together by the removal of water molecule forming a peptide linkage, and these amide group, when linked with the carbonyl group forming chains, forms a polyamide resin. Polyamide resins are the thermoplastic polymer materials consisting of primary chains formed by repeated amide bonds. The chemical definition of polyamide resin involves the presence of amide functional group, which is C double bond O and H within the polymer backbone. The thermoplastic polymer is the property allows them to be melted, reshaped, and recycled. Moving toward the history of polyamide, the concept of synthetic polymer began gaining attention in the early 1900s. Scientists explored the possibility of creating artificial fibers that could surpass the properties of natural fibers such as silk, because silk was mostly used at that time. But the polyamide resin was introduced to the world in 1935. The history of polyamide resin began in 1935 when Valek, co-authors, and his team at DuPont developed the first synthetic polyamide known as nylon 66. This breakthrough material was introduced commercially in 1938, revolutionizing the textile industry with its strength and elasticity. Strength and elasticity are the most unique properties of the polyamide resin. Nylon became widely popular during World War II, replacing silk in parachutes and military supplies. Polyamides were originally developed as materials for synthetic fibers, but their outstanding physical properties, like high tensile strength and low friction corrosion, also high mechanical strength, heat resistance, and thermal stability, makes it a very unique polymer, eventually led to their adoption as injection molding materials for a broad range of applications for automotive and industrial components to household appliances and beyond. Injection molding is a highly precise and cost effective manufacturing process widely used for producing parts of polyamide resin, also known as nylon. Following is the chemical structure and types. The chemical structure, the general structure of the polyamide resin can be represented as follows, containing the amino group at one end and carboxylic group at the other end, attached with the carbonyl chain. The N is representing the number of the carbonyl group or the number of carbon atoms that are attached with it. Discussing the types, polyamide resin involves two types that are given below. One is the aliphatic polyamide and the other is aromatic polyamides. Aliphatic polyamides are the simpler ones, while the aromatic polyamides contains the ring in their structure. Examples of aliphatic polyamides are nylon 6, and nylon 6,6, while the aromatic polyamides are Kevlar, poly phenylene terphthalamide, and nomics polyam phenylene isophthalamide. Discussing their structure, nylon 6, the 6 is representing the number of carbon atoms in the structure. One of the carbon atom is of the carboxylic and the other are of the carbonyl group attached with the amino group. As it is written here, one is the amino group, the other is the carbonyl group, which contain 5 carbon atoms in it, and one is the carboxylic carbon atom, forming 6 carbon atoms and forming a structure polyamide 6, also known as nylon 6,6. Same for the nylon 6,6. It contains the 6 carbon atoms at one end and the 6 carbon atom at other end. The 2 carbon atoms in this case are of carboxylic group and the 4 are of the carbonyl group, and at the other side contains 6 carbon atoms. Discussing the aromatic ones are the Kevlar. The poly means that the compound is the polymer, and P is representing the para position, which is the 1,4 position. Phenylene terephthalic amine is representing the benzene ring, which contains the amide group and the carboxylic group at 1,4 means para position. In case of Nomex, which is the polymer containing the benzene ring having the amide group at 1 and 3 position. All the monomers combine together forming chain of polymer, ultimately forming a big polymer of the polyamide resin, which is widely used in today's application in every field of industries. Talking about the manufacturing, it contains 3 production processes: monomer synthesis, polymerization, processing techniques. In monomer synthesis, are the subunits that combine together forming larger units, polymers. In monomers are the nylon 6 and the nylon 6,6. While in polymerization, 2 techniques are used, which are ring opening polymerization and step growth polymerization. In ring opening polymerization, in case of the production of nylon 6, caprolactam is a compound containing a ring structure which is broken down to form polyamide 6. As we can see, the ring is being broken down from here. The carboxylic group and the amide group, amino group are being broken, and the polyamide 6 is formed. While in case of polymerization, condensation reaction is being occurred here. One of the hydrogen atom is being removed from the hexamethylene diamine, and the carboxylic acid containing 4 carbonyl groups forming adipic acid is removing one of the hydroxyl group. The hydrogen and the hydroxyl group join together forming a water molecule, and the remaining ones attach together forming polyamide 6,6. Processing techniques include injection molding, extrusion, and blow molding. As discussed above, injection molding is a high precise and cost effective manufacturing process widely used for producing parts from polyamide resin. It is common for producing automotive parts, consumer goods. In extrusion, the raw material polyamide resin are fed into the extruder hopper, and then they are melted and mixed together. Then they are shaped, and after shaping, they are cooled and the cutting is done, and then the surface treatment is given. It is used for creating fibers, films, and tubing. While the other one is the blow molding, which is same as the above one, but this one is used for the hollow objects like bottles and containers. In this, a different kind of machine is used to make the objects and reshape them. Talking about the properties include mechanical properties, thermal properties, chemical resistance, moisture absorption, and wear resistance. Height, tensile strength, and impact resistance, good toughness, and flexibility. The flexibility allows it to bend, stretch, and convert to different shapes without breaking, while the tensile strength makes it to be molded in any form or any shape required. The thermal properties include high melting points, nylon 6 220 degrees Celsius and nylon 66 265 degrees Celsius. Means these polymers can withstand any temperature, the mentioned one. Good thermal stability over a wide range of temperature, chemical resistant. In addition, polyamide also exhibit good chemical resistance to oils, grease, fuels, and many solvents. This resistance makes it suitable for applications in harsh chemical environments such as automotive, fuel tanks, and chemical storage containers. Moisture absorption, hygroscopic nature absorb moisture, which can affect mechanical properties. Moisture containing conditioning can enhance flexibility and toughness. Moisture is the one thing which is uh, taken in consideration while making polyamide resin because moisture can alter its dimension and the shape of the polyamide resin. So, precautions are taken according to the moisture and the temperature. Moisture absorption can cause polyamide to swell, leading to dimensional changes in molded parts or extruded profiles. The next one is wear resistance, excellent abrasion resistance, and low friction coefficient, making them suitable for moving parts. Abrasion resistance refers to the material ability to withstand wear and corrosion caused by friction or rubbing against another surface. For example, uh, in textile applications, nylon fibers are known for their excellent abrasion resistance, which help them withstand friction from everyday use and maintain their appearance and integrity over time. In engineering applications, nylon components such as gears, bearings, and bushings benefit from their abrasion resistance, ensuring smooth operation, extended service life, even under high stress conditions. Moving toward the application, automotive industry engine components, polyamide resins are used for parts like timing belts, fuel lines, radiator and tanks, air intake manifolds, and oil pans due to their strength, heat resistance, and durability. Interior components such as seat belts, airbags, interior panels benefit from toughness and wear resistance for polyamides. Connectors, sensors, and housings for electronic control units (ECUs) are often made from polyamide resin. Another one is the textile industry. Textile industry include fiber and fabrics. Polyamide fibers such as nylon are used in apparel, carpets, and industrial fabrics due to their elasticity, strength, and abrasion resistance. Sportswear also include polyamide in them. High performance sportswear, including swimwear, athletic apparel, utilize nylon for its quick drying and durable properties. Insulating materials such as that we see in our households, like wires and other stuff, polyamides are used in cables insulation and electronic components due to their excellent electrical insulating properties and thermal stability. Connectors and switches. The robustness and precise molding capability of polyamide make them ideal for connectors, switches, and circuit breakers. Robustness refers to the ability of material or system to withstand variations, disturbances, or adverse conditions. It is also used in the consumer goods, household kitchens utensils, cooking tools, and small appliances often use polyamide resins for their heat resistance and durability. Durability is the ability of the material to withstand wear, damage, or deterioration over time. Sport equipment items like fishing lines, tennis rackets, and camping gears are made from polyamide due to their strength and flexibility. Also, in the packaging industry, polyamide serves as great component. Food packaging, polyamide films are used for vacuum packaging for food products due to their excellent barrier properties against gases and aromas. Industrial packaging, used for heavy duty packaging materials that require durability and resistance to puncture and tears. Also, it serves in construction industry, fasteners and hardwares, screws, bolts, and anchors made from polyamides offer high tensile, high strength, and resistance to environmental degradation. Composites, polyamide resins are used as a matrix material in fiber enforced composite for applications requiring high strength to weight ratios. High strength to weight ratios means a material with a high strength containing low weight. In medical devices, our polyamide resins play a great role. Surgical instruments and medical textiles. Polyamide are used in manufacturing of surgical tools and components due to their sterilizability and mechanical strength. Nylon fibers are used in medical textiles such as sutures and bandages for their biocompatibility and durability. Biocompatibility refers to the ability of material to interact with living tissues or biological systems without causing adverse reactions or harm. Also, in industrial equipment, gears and bearings, machine parts, polyamide resins are used to manufacture gears, bearings, and other mechanical components that require low friction and high wear resistance. Machine parts, components such as conveyors belts and bushings are made from polyamides for their toughness and longevity. Longevity, the ability of the material or product to endure over time, maintaining its performance and structural integrity. Some of the practical considerations regarding the use of the polyamide resins. Taking full advantage of unique property, polyamide require paying careful attention to several practical considerations. Among the most important of these are proper moisture control during the formation process and awareness of the impact of the moisture on product performance. Following figure shows the results of an experiment quantifying dimensional variations in a formed polyamide component held at rest for a long period of time. In this experiment, a slab formed from the polyamide was held for 2 years in measurement chamber with temperature and humidity uncontrolled and measured at regular intervals. Starting from a fully moisture depleted state, the dimension of the slab increases over approximately the first 6 months due to their water absorption and other factors. Thereafter, the slab dimensions vary periodically due to seasonal variations in temperature and humidity. Some practical consideration regarding polyamide also include processing conditions. It is essential to optimize processing conditions to achieve the desired properties and minimize defects such as wrapping, shrinking, or surface imperfection. As above mentioned, moisture sensitivity is one of the concern in forming polyamide resin. It's designed for manufacturability and the mechanical properties like understanding the mechanical properties of polyamide resin, including tensile strength, impact resistant, and fatigue resistant, to ensure the material meets the performance requirement of the intended application. In conclusion, polyamide resins are the versatile and essential class of polymers with a wide range of applications across various industries. Their unique combinations of mechanical properties and thermal stability, high tensile strength, and other unique properties like chemical resistance make them suitable for demanding applications. Its lightweight nature, coupled with high strength and chemical resistance, has led to innovations such as lighter vehicles, stronger textile, and more durable engineering components, revolutionizing product design and performances. Continuous advancements in formulation and processing techniques further expand their utility and making polyamide resins integral to modern material science and engineering. Thank you.